Hi guys, welcome to this brief thing which you might have seen on Space Cadets, to be fair, hence we've still got the same stuff I'm working through. Don't worry about any of this, it's just happens that I've done this for Space Cadets, but it's pertinent to where you are now for your observational tasks. This may help you. So we're going to be looking at here the age-old question of which telescope should I get? Well, this presentation is more about learning the types of telescopes that there are out there and what's best suited for you. Getting the best type of telescope, it's like choosing a car, and many of you might not be there yet. Some of you may be taking driving lessons. But you've learnt from your parents possibly, and indeed if you're a mature learner who's already gone through all that and got your car, you will learn that the choice of car depends on what you want it for. You just want a town runabout, so something cheap and cheerful might do for that. Or you might be driving long haul and need something with a bit more comfort, aircon or sunroof, and maybe a little adapter there for your coffee. So all these have a bit of a sort of a decision on the type of vehicle you are going to get. You may intend to get one that you can cart a lot of stuff around with, so never mind the car. You may need a transit vehicle. So what's my point to all this then? Well, telescopes are exactly the same. And depending on what you want to do with it, depends on which telescope you get. For example, with me, you may have already gathered, I don't have one telescope, I use several. In fact, I think at the moment I'm using about 3 different types of telescope at once. And I do. Well, 2 telescopes at once, a third one's coming online soon. But ultimately, they've each got their uses, which we'll be discussing now moving forward. What you weigh up before you buy a telescope, you've got to consider the following. The cost. Firstly, these things aren't cheap. So if you're going to invest in a telescope, make sure you get one that is at a price you can afford. And understand that when you buy it, you're not going to want to get another one, in the very sort of close future, because these aren't cheap. So you're going to be wanting to do a lot of groundwork here, a lot of research here before you've got to know what your budget is, and preferably not spend months paying it off on a credit card. B, the physical size, and you'll see what I mean about this later on in this presentation. Physical size matters a lot. You might use a small one like the now C stars that's now out there. Unfortunately, I haven't focused much on that in this presentation, but it is out there, and it's the physical size I can assure you is very small indeed, and the setup is dead easy as well. But there are some setups which take more time. So you've got to consider that, setting it up could be anything from picking it up, plugging it in a garden, to more polar alignment, leveling, and other things. So you've got to consider what your mileage is for that. What do you want to use it for? Right, well, you've got certain telescopes that are best for the moon and the planets up that end, and you've got sort of smaller field of view with these predominantly, and then you've got the other end, which has got a wider field of view, which is going to be better for nebulae and some star clusters, and indeed some galaxies. So you've got to consider that, and also consider binoculars, people, because if you're going to go and spend a couple of £100 on a telescope and then chuck the hobby in after, you're not going to be able to use that for too much more, really. I mean, it's going to be too cumbersome probably to move around. You might use it for wildlife stuff, but ultimately, a telescope is used for what it's used for. Whereas with a pair of binoculars, you can generally use a pair of binoculars for, bird watching, or if you're at the beach, you can look at the ships as they go by. Binoculars do have a wider intrinsic value, and they're very good for astronomy. And if you're looking to learn the sky, then there's nothing better than laying down in a deck chair and having your binoculars and having a little gaze up as you're learning your way round. And that's how I used to do it. So these things are to consider moving forward. What is the right telescope? Binoculars, I think I've already gone over a lot of this, but a good pair of binoculars is good for basic stargazing, and there's a wealth of things you can see with them. And they're also inexpensive, but I've already gone through all that anyway. But there's a few things that I might not have already said before. Cost, I think I've already said that. But one big message in there that I'm going to throw out again The best telescope is the one you use. I'll let you into a little secret. I've got a 10-inch Dobsonian down there, and it's got a thrust tube which makes it collapsible. But it's not the main telescope I use because A, it is very heavy to get it out. B, it keeps needing collimation when I have it out. And C, because it's quite low down, I have to wait longer for objects to come into field of view before I can get my eyepiece on it. So that telescope, for the price I've paid, which was about £1,000, doesn't really get much use. So it's a bit of a waste of money. On the other hand, I've got telescopes that are cheaper than that, which do get used. So yeah, and as it says there, no one size fits all. That's important. Aperture, that's diameter of the mirror or the objective lens. We discussed that in the night sky module in Space Cadets. Essentially, you can think of aperture as a bit like a bucket. So if you're out in the rain and you want to catch some rainwater, what are you going to go out there with? You're going to go out there with a couple of glasses like that, perhaps even maybe a pot that big, so something like that to gather it. Or might you get big buckets, trays, things like that that are far wider to catch more water. The same is true for astronomy because light, like rain, falls out of the sky, bombards us, all those photons of light, and the more of these we can capture, the more of the object we can see, the more detail we can see, and the deeper into space we can go. Unfortunately, for that privilege and for that property of light, the larger the aperture, the more it's going to cost you. So that's another thing to consider there with that. Physical size, I've mentioned that, but here's a few. I can actually update that now, believe it or not, with the C-SLARS telescope, but you can kind of see what I'm going at from here. I've got my main setup there on the left, which is covered over. That's my main telescope that I keep out there, semi-set up. And on the right is our friend, the 10-inch Dobsonian. And as you can see, it's sat there on the trolley behind a mountain bike. I constantly get moaned at about it because of the space it takes up. And that thing, for the money I have spent, has been out in the garden probably 2 or 3 times since I bought it. What a waste. How long have I had it for? Couple of years. The idea behind it was to have it available for outreach, but not having a car big enough to take it in a boot easily became another problem. So it was a nice idea, but it sat there. But either way, that might not be a waste of money for you. You might have a nice corner by your patio doors, where on a clear sky. See the handles there? There's one on the other side. There's a handle there on the other side. You can grab that and carry it through. I don't recommend getting that one because obviously you can collapse it down for travel. But there's another type there, same kind of make, but a full solid tube, which is lighter and easier to move around. That one there is motor driven, so you might not want to get something as meaty as that. Oops, but yeah. But that takes up a lot of space. So that's the physical size to consider. And the setup, I really do go rambling on, don't I? I've already kind of covered this as well. So there's the setup here. So obviously the one in the middle is going to be quite easy to set up. You can plonk and go. There are disadvantages with it, but you can easily see what you need to see with it. That one over there, you can plonk and go, carry it out, put it down. If the finder hasn't been moved, then that should already be aligned. And all you've really got to do maybe is check the collimation, and then you should be able to run with that. That's why the Dobsonian, which was invented by John Dobson, the late John Dobson, I should say, he invented that. And then you've got my other setup over there that people really sort of know me better for, that I tend to use. Why do I go for that over that? Well, that's a bit quicker for me to set up. It's higher off the ground, and I image with that, take pictures, and I suppose because it's higher up, I can see objects far more quickly than I can with the one on the right. And also I can throw a cover over the one on the left. I can, technically speaking, do it with the one on the right, but the mount's made of wood, and we know that moisture and wood do not go too well. So if I left it out there, the mount's going to become quite damaged by the moisture. But it again comes down to setup because for you, the one on the right might be ideal for you because there are less things you need to be concerned about. Polar alignment isn't going to be a problem with the Dobsonian. Leveling, yeah, I mean important, but again, all you're doing is pointing and looking. So it's an easy thing. But collimation, that's where the optics are out of alignment, will be an issue with that one, and trust me, it is. And that's a 10-inch mirror that you've got down there. So it's 10-inch aperture. That's good for planets, that is. So these are the different telescope extremes and the relative setups that you're looking at. And by that time, you've had a look at the leveling and polar alignment that comes with that one. Yes, it's a problem, but because of the weight of the ship, the weight of that mount, I don't have to keep on adjusting the leveling too often. The polar alignment has been mastered to a fine art for me, so I don't worry too much about that. But that depends on your flavour. Also, time to take it away, time to take it down and put it away is you can't leave it out. Security, you might not want to leave any of that outside. My garden's enclosed. I do worry about the security there, but generally I tend to bring the telescope and all the equipment in, and the other parts tend to stay outside. And touch wood, I haven't had a problem with that. Three types of telescope to consider. We'll get to mounts and tripods next. Okay, so refractors, that's generally this type of telescope. So you're looking through the telescope, light's coming down through here. That's a star diagonal. So that then focuses the light up so you can see the light. So that's how a refractor works. That's a reflector. I think I've got diagrams for these anyway in this presentation. But anyway, the purpose of this is to tell you that we've got refractors, reflectors, and Dobsonians, because, well, that is still a reflecting telescope. We're talking about the mounted side in this case, and a Schmidt-Cassegrain telescope, which is that thing over there. There we are. Refractors then, here we go. So these are based on the celestial ones, which appear to be fewer and far between now for some reason. So this is how they work. Kind of already briefly described it, but that's how it works. So you've got the focal length here. That focuses the light down from the lens, and then the eyepiece will then magnify that so you can see your object. That there is the refractor. And these are best for planets, the moon, and brighter galaxies like clusters and nebulae, because basically, intrinsically, the lenses are smaller. The aperture is going to be smaller. So the light gathering capability of these isn't going to be as great as other flavors you saw earlier. But they're great beginners telescopes. I started with a 60mm alt-azimuth telescope. There's nothing wrong with it. I saw my first view of the moon with a telescope like that. I saw my first view of Mars with a telescope like that, Jupiter, and also solar projections I did with a telescope like that. Got me into it, didn't cost much. Well, it might have done back then, but it certainly went and got me going. And here's so the pros and cons then. We'll be going through these for the other telescopes. Pros are it's simple to use, lower maintenance, absolutely. Generally cheaper, ideal for brighter objects and it's lighter. So, simple to use, plonk it, make sure the finder's aligned, and then beyond that, go with it, have fun. Lower maintenance, yes, a collimation, you're not going to knock the lenses out of alignment. You might need to occasionally clean it and, let the dew evaporate off, but you don't have to worry about these things too much. Bring it out if it's wet, leave it somewhere to dry, put it away, you're good. And yeah, cons. Okay, higher apertures are more expensive for refractors. Yes, they are. And they're more expensive than their reflector cousins, so understand that one early on. The higher the aperture, the heavier the lens. That's going to be for any telescope. The bigger it is, the heavier it's going to be. Unfortunately, there's no real way around that. I mean, that Dobsonian you saw really does weigh a ton. It's difficult to move. But not so good for fainter objects. We covered that earlier. Can be awkward bending low for the eyepiece. Well, if you've got a star diagonal like that over there, you shouldn't need to. And poor star diagonals can give ghost images. Yes, well, my first ever telescope never had a prism in it. It had like a flat mirror. And of course, with any mirror, what you get, you get double reflections, from the light that comes in. So I've seen double the images. But last time I looked at the night sky, the first view of the night sky, I saw a whole load of double stars. And naive me thought that that's what it was. I was only 13 at the time, been in the game for about 20 minutes. But, quickly learnt why that was. And if I took the star diagonal out, then I never saw double anymore. So, yeah, those things are worth considering anyway. Reflectors, here we go. That's just one popular type many have got. And this is what we have here, a primary mirror down there. And I said, I'm sure I did this one myself, though. Anyway, light, whoops a daisy, light comes down, reflects off the main mirror, up to a secondary mirror, and then up to the eyepiece. That's pretty much how that works. Yeah, so that is a reflector. The pros. Cheaper for greater aperture compared to their reflector cousins. So they are cheaper than they used to be. I mean, if you wound back 20 to 30 years ago, you'd need a mortgage to buy a bigger one of these. Now, not so much. I mean, I suppose it's because the manufacturing costs have come down, so therefore the telescope prices have as well. You can view fainter objects, absolutely, because you remember the bucket analogy, wide the mirror. Yes, you can view fainter objects. Less awkward to observe from because rather than being down on the ground now, you can now look at the side, which can make it for easier viewing. And no colour fringes. Well, yeah, I mean, compared to a refractor, you may see some colour aberration in a reflector depending on the on the type of telescope and how cheap it was. Where it comes from isn't for now, but yeah, just understand that can be an issue. Cons: the mirrors are fragile. Yes, they are. If you get some dirt on one of those, you're not going to go out there and clean it. Because it could damage the silver coating because the silver coating is on the front of the mirror there. You don't know it's damaging that. Hard to clean the mirror, absolutely. In fact, I'll tell you a story about that 10-inch Dobsonian later. Well, needs collimation. You're not kidding. That big telescope I showed you needs it a couple of times every time I'm out. An open tube, why is that a problem? Well, flies and insects can come in, land on your optics. You don't want that. If you're in the north of Scotland, you certainly don't want that with the midges. Big problem. Bulky and often heavy. Oh, you're not wrong when you consider the bigger end, larger end reflectors. I'd say you're generally okay there up until about a 6-inch reflector. And then when you get to 10-inch, the bulky and the heavy certainly starts coming into play. So, yeah, those are the things to consider with reflecting telescopes. The Schmidt-Cassegrain, and this is a popular flavour many people have got there, the old Nick Star series. That looks like about sort of maybe a 6-inch, maybe. It's always hard to tell in a photograph. But these are quite the popular beginner's end that many people have got there. And they're becoming more popular with amateur astronomers compared to 20 years ago. The prices dropped quite dramatically. They've got the features of both refractors and reflectors. You view from the end, as you can see there, because that's where the eyepiece is at the end. So because it double reflects up and down the tube twice, you've then got the eyepiece there in a hole in the mirror, because that's the part of the mirror that doesn't get used by the secondary, as you can see there. That's why they've put the eyepiece there. And yeah, the objective is a corrective lens to ensure that the focus of the light enters correctly. And these are good all-round telescopes and for deep sky, but they've got a limited field of view, which means they are a pretty good intermediate thing, but you might struggle to get the full moon in that, and possibly even the Great Orion Nebula. So that's the kind of field of view you're talking about with one of these. Very good for planets, though, and very good for the moon if you're interested in detail. But yeah, that's how they work. So you can see the main mirror reflects up to the secondary mirror and down through a hole. And there's the corrector plate there. And there's no credit for this one because I did this specifically for this tutorial. Not too bad, even if I say so myself. Let's see if I can set it and make some royalties. Okay, so the pros and cons of this then. Okay, pros. It's cheaper for greater aperture. Well, that doesn't mean to say a 6 inch is going to be more expensive than an 8 inch and a 10 inch. No, but what it does mean is it's not going to cost the order of thousands to get bigger apertures. Fainter objects will be available in its field of in its range. No colour fringes, good for astrophotography because that's all people want to do these days, take pretty pictures, and good all-round telescope with a sealed tube. A sealed tube, that's what I like about using that kind of telescope, the sealed tube, because it means that when you're out, you're not going to get any flies or anything flying into the thing, because unless you leave to take an eyepiece off and go for a cup of coffee for some reason, um, as long as you keep that end part sealed, nothing's going to fly in there. And I've had it with mine that I've noticed that a fly flew into mine. And what it did was it's obviously found its way in, bounded around in the telescope. Fortunately, it didn't touch the mirror, left a bit of a mess inside the actual corrector plate though, and I had to use to be quite creative with fishing it out. I had to use a bit of garden hose, feed it through the tiny hole where the eyepiece sort of goes, and then attach it somehow to a vacuum cleaner and then suck it out. Yeah, you have to get creative sometimes. No cons then. Needs collimation, yeah, but not as readily as a reflector. Bulky, oh yeah. And you have to find someone to put that when it's not in use. Often heavy, oh yeah, certainly heavy. Prone to condensation, yeah, you can get that on the corrector plate, the condensation, and there is a workaround for that. You can use a hairdryer. If you plug a hairdryer, you can blow the dew off of the corrector plate, and depending on how bad the condensation is, that'll give you anything from a couple of minutes to get some astronomy done to a little bit longer. But condensation is going to be a problem for those, and indeed as well with the Newtonian, truth be told. Mounts. Oh, okay. So for the optical tube assembly, aka the reflector, and SCT, we need to have it sat on something. And we've got a choice here of an altazimuth, equatorial, or Dobsonian. Altazimuth and Dobsonian can be bunched together because they are pretty much one and the same, but we're going to discuss what these are. The Altaz mount, yeah, I started off with one of those. I mean, they're great to use. I mean, there's no real setup, but you do have to undo the thing, move it around, get it into your eyepiece. Once it's there, tighten it off, take a look. And the Earth's rotation, it moves as it does, and the object drifts out, and then you've got to go through the whole process again. But it is a quite simple thing to use for the beginner who just wants to have a gaze. Pretty good instrument, that, quite cheap. But that there is the Altaz mount. So, yeah, good for beginners. Yeah, okay, pros and cons. Here we go. Easy, simple and easy to store. Yep, lightweight, certainly. Easy to operate. Yep, quick to set up, absolutely. Good gaze amount for the absolute beginner. So, yeah, like I said, if you just want to get something into the field of view, have a quick gaze at it while it wanders back out, then fine. But yeah, generally quite cheap, absolutely, and better for brighter objects. Better for the planets and the moon than that one. The cons then, and I've already probably kind of mentioned some of these. Don't have long to view because of the Earth's rotation, yet we said that. Easily knocks off target. Oh, I've done that. You get the thing into field of view and suddenly you knock it with your shoulder or something, and you're not very pleased with yourself. Worse if somebody else does it. Prone to the wind blowing, absolutely. So I just need to prone to the wind blowing them around. Absolutely. I've often compared having, say, Jupiter in field of view there to like having a tadpole moving around inside the jar. It's never going to sit still for long. And when you've gone in and you've focused it, it's going to wobble again. And if you want to focus a little bit more, gently, it wobbles again. And then after all that, zoom, it's gone. So what you're going to hope is you've got the focusing right. So you're going to go back and then image it to study it again as while it's going through, trying to make out as much detail as you possibly can. And that's where I said time to stabilise needed after getting the object into field of view. And finally, with the out-hours mount of that slaver, you cannot fit drives. That doesn't mean to say you can't fit drives to any out-azimuth mount. No, that's not strictly true, just not that one. Anyway, moving on. Equatorial. These enable the observer to set the telescope up to enable tracking of any object. Yeah, they are far more easy for that. They have to be aligned to the pole with the tube balanced. I've gone into more of that on Space Cadets, but again, as I say, this is a Space Cadets presentation, so please excuse that. The photo opposite shows a refractor mounted, but it could also be so you could have a reflector on that mount as well, in other words. Notice also how you've got these rings. That enables you to loosen these, move that tube up and down. So if you want to put a camera into that that's a bit heavy, pardon me, you can balance that by moving it up and down, or indeed you can slightly rotate it if it's easy to look down like that rather than like that. It's easy for you to look down on, and it also brings the finder into better view as well. And you've also got these micro screws, which mean once you've got it in field of view, you can gently move that bolt, that nut, and still keep the thing in view. That is only going to work if you've got it polar aligned. This one looks slightly low for these latitudes of 52 degrees, but you want to get this sort of line through there and about roughly 52 degrees for it to be polar aligned. And you would do that using that bolt there to move it up. Then you'd screw it off once you've done it. And then you can loosen the bolt underneath that if you need to move it a bit more that way. You don't move the actual assembly for that, for polar alignment, but that's something for another video. It does get more involved, doesn't it? Moving on. So equatorial mount pros and cons. Okay, pros, simple, easy to store. I wouldn't say an equatorial mount was as simple as an Altaz or as easy to store, but yeah, okay, you can fold it up and put it in a cupboard somewhere still, but you've still got that weight on the end, which you might want to unscrew and put someplace else. More stable, yeah, because you've got the weight of the whole assembly with the counterweight. If you remember back, you've got a counterweight here, and that does help the stability of the telescope as well. What did I miss there? Well, allow easier tracking, we said that. Less easily knocked. Yeah, I mean, don't get me wrong. It's not going to be like a brick. If you knock it, it'll still cause problems, but it's a bit heavier and a bit more tolerable to that. Less prone to the wind. Yeah, even my heavy one can still get blown around, but it's less prone. Yes, that's fair. And many cases, drives can be fitted. Yes, they can. Drives can be fitted to these. And that's not unheard of. You can fit drives to these. They might not necessarily be perfect, but they'll give you a bit more tolerance for some of the work you're doing. And they're quite inexpensive these days too. Okie dokie. They can allow for some astrophotography, but you're not going to get the high-end stuff everybody else does. But you can still get something done. You know, if you put that on planetary, maybe a bit of lunar. Anyway, moving on. So cons, more expensive. Yeah, not much more expensive. I mean, you could buy a telescope like that now for about 115, 120 quid. More complicated to set up? Yes. Need to balance the tube. Yeah, balance the tube. Very briefly, what that means is if you have it set up like that and you put a whacking great big heavy DSLR camera in there, which you can do, you're going to make that very, very heavy and place more pressure and strain on the gears. So you have to basically balance it so it's easier for the telescope to move. That's why you've got those rings to loosen and move things up and down. And if you're looking for a telescope where you're planning to go that way, you need that degree of flexibility. And the other way to balance it as well, guys, is if you put more weight here, you're going to have that one adjusted down there as well to cater for that. So if it's not so heavy, you're going to move it further up. I mean, for this setup, I'd say that's a bit too far down. You probably need that a bit further up for this kind of assembly because you haven't got much on that. The more that you put on, the lower down that way it's going to have to be. And that aids with the movement this way and with that way. Because if you don't balance it properly, you're going to put a lot of strain on the gears. It's going to be very difficult for you to move. And even though the first flight might not cause too many problems, if you continue on that course, you're going to start damaging your gears. So it's not worth going there. And it only takes a couple of minutes to fix that. Yeah. I finished it. Yeah, okay. Right, Dobsonian then, and this is the other one I was referring to. You can see my old faithful one down there, but same flavour. The only difference between that one and that one is that doesn't have a truss because you've got like poles here that extend up. This whole thing pulls up. That one's a solid tube, and yeah, that one's got a built-in motor. That doesn't. And believe it or not, guys, when I made my purchase, I kind of half wish I went for the one on the left and the one on the right. But I went for the truss tube one so I could get it in the cupboard under the stairs there, whereas that one wouldn't have gone. Anyway, the greater aperture for the so basically with Dobsonians, what we're saying there is for to get the best bang for your buck, the Dobsonian is going to be the way to go. This is an all-round telescope. It most certainly is, guys. That is a 10-inch mirror, that one. You can get 6 and 8-inch. And, when you get it out there, the view of the planets is going to be far more superior, many people say, and I agree, with that telescope than with any other kind, especially with the 10-inch. It's like that magical aperture there. So people but also it depends on your conditions. I mean, if you've got light pollution, you might not make best use of a 10-inch. You might want a 6-inch or an 8-inch to consider that. Um, but they're easy to fold away, and and you will not see refractors mounted on that. Yeah, rambling on here. Essentially, though, there's the finder. So once you get the finder aligned to the tube, as long as you don't move that finder, that is going to be right every time you carry it out. And that telescope can be carried out, plonked down, do your astronomy, pick it up, plonk it back in, and that can live wherever, in the corner by the patio doors, cupboard under the stairs. The only thing I will say is wherever you put it, try to make sure it's reasonably close to the door so you can, without limited thing, pick it up and carry it out. You want to get to the point where you won't be gazing out the window. What's that bright object out there at night time, of course, and think, oh, okay, let's go up the telescope and have a look. And that's the kind of idea with these things. It's supposed to be a kind of drop it and go kind of thing. So that, ladies and gentlemen, is the Dobsonian. I do like it. The only problem I've got with it is, for me, the mirrors are often out of alignment, especially for mine. But not everybody reports that problem. So yeah. So pros and cons then to this thing. Okay, the pros are, I always say simple and easy to store, don't I? But in this case, it is. Easy to store, yes, in theory, and I mean in theory because it's also going to be bulky. Easy to use, certainly. Greater aperture for less money. Yep. Quick setup. Yep. Good for the planets, moon, and deep sky. Absolutely. The cons. It's bulky and heavy, like I said. Harder to track. Yeah. So with this, you've got that little handle underneath there, which you need to hold to move the telescope around easily. Another problem you're going to have with this as well, you can't rotate that tube. You're going to be stuck at that orientation regardless of where the telescope is. And it can be hard to orientate yourself to look through the finder scope as well. That's another thing I've noticed with these. So you don't get the tube rotation like you saw with the refractor, and you can't, you're stuck in that orientation. That's the main problem you'll find. With that one, I don't have that because it's in field of view. I've got the little handset that I can move it around with. A bit lazy, so maybe I'm cheating, but nevertheless, it works for me. And yeah, not ideal for astrophotography. No, you can take afocal pictures. Yes, you can take pictures of the planets when you might put a webcam down there and allow planets to drift across the eyepiece. That, yes. Mirrors are prone to damage. Okay, I'll tell you my story now. That telescope I've got here, remember, yeah, but I've got a young girl, young daughter who likes to wander around at the back there, and I've got a dirty, great big brown stain on the mirror. And I don't know yet whether that's chocolate or something, because I think what she's done is she's taken the dust cap off the main thing and dribbled down the tube. And now I've got a dirty, great big brown stain down a 10-inch mirror. My prime instinct is to clean it, but rule of thumb, unless it's affecting your astronomy and you're observing, you do not touch the mirror. And as irritating as it is for me to leave it, I've left it. But obviously, if I was going to sell it at any one time, I would probably then attempt to clean it, because that's the only thing devaluing in the telescope other than anything else. But that is the one problem there. The mirrors are prone to damage. And the rule of thumb is don't try to clean the mirror unless you absolutely have to. And there are points and times when you're going to have to get the mirror resilvered by someone. So the silver may start to flake off for a while. That's severely, affecting the telescope's ability to do anything, and that's when you have to send it back. Collimation issues. Oh, the Newtonian is famous for it. So if it gets if it gets a slight knocking and you knock the mirror or the secondary mirror out of line, what that means is um, if you pass a laser beam through the eyepiece, it should go back down and come back and go back through the hole in the laser collimator. That's how that's supposed to work. Um, but it doesn't. If it's out of collimation, it doesn't. And what it usually means is on a lower magnification, you can probably see the moon or the planets quite well. But the more that you magnify in, the blurrier it gets, and you can't focus it easily. That's where collimation is a problem. So collimation is up there with polar alignment and leveling as the astronomer's chief headache. So I use a laser collimator for that. And yeah, I think I've discussed how to use that in another video, but that's not for the scope here. Conclusion. Choosing a telescope can be like choosing a car. I've already said that. But it's down to what you want to use it for. It really comes down to what you want to use it for. A Schmidt-Cassegrain telescope is going to be better for narrow field stuff, planets, star clusters, some galaxies, the moon, ideal there. If you're looking for wider field stuff, for nebulae and star clusters, that kind of thing, you're going to want maybe a refractor that might be better for use there, or maybe a reflector could be better. If you take the focal length of a telescope, divide it by its aperture, that gives you the focal ratio. And the higher that number is, the smaller the field of view is going to be. The lower that number is, the wider the field of view is going to be. So lower field of view is better for the planet. So my Schmidt-Cassegrain is an F10. Yeah, so if I take, I forget what the focal length is, 1,000 something, divide it by the the aperture in millimeters, whatever that is, and that gives me 10, which is quite high. And yet for the other telescope I use, it's a fair bit lower. So I could throw a lot more information into that that's going to bamboozle you, but I don't want to do that. So what I've tried to do, and I'm going to go into a little bit more as well. I'm going to go into a little bit more with you before I close this down. So let's come out of that and then come into this. Very briefly, I want to discuss this with you before you go. So polar alignment, this is where you've got your mount as your weight to give you some bearing. And if you remember, I pointed out that nut, the previous picture, that's where that would be. That isn't here because I haven't drawn it, but this is more based out my big setup, but the principle's the same. So what I'm doing is I'm getting the pole star aligned through here. That's what I'm doing, as close as I can get it. And I'm only going to use the nuts in there and here and rotate this whole thing to get it polar aligned. That's what I'm going to do. How do we find the pole star? Well, that's Merak and GP. This is the plough, my crude drawing of a plough. Draw an imaginary line up and you will hit the pole star. And that's quite useful because the pole star's quite lonely up there. It is the only bright object up there, so you can't really mistake it for much else. Fortunately for me, if I'm trying to find it another way. But that there is polar alignment, and this says the mount needs to be level. So this here needs to be level before you put that on. This here needs to be level. How do you do that? Spirit level, quite simply. Um, Not going to discuss how to do that here. That there is an easier way of doing it. Um, but there are YouTube videos to discuss how to level them out, or I might have to do one as well. What else have we got? Eyepieces. So this is a lot of what you may get with your telescope. And I know you must be tired to hear my voice now. But if you bear with me for a bit, I'll just quickly steer you through what we have here. So star diagonal, this is one close up. So you've got that goes into your telescope tube. Your eyepiece will then go in here. And in here, you typically have a prism, which allows you to, allows you to more easily observe. And that's handy because rather than being like that underneath the tube on the ground, you can be looking down a bit more comfortably, albeit simply may still be on the ground, but you could be a bit more comfortable. Plus, also, you can loosen the nut on the side of your focusing tube, and this thing rotates. So it doesn't have to be up there, it could be here or down here. So you can rotate it around, and that's not going to affect the focus. So you can do that. And you have got your eyepieces. We all need eyepieces, don't we? And I've got some crude ones there, but what I want to draw your attention to are those numbers. So 25 millimeter, 12.5 millimeter, and 7 millimeter. These are all the focal points of the eyepiece. Rule of thumb, without describing how you work out the magnification, the stronger lens is going to be on the right hand side. That's 7 millimeter there, and you really don't want to go much below 7 or 6 millimeter because typically the little holes you look in are really dead small, which isn't going to be easy to find in the middle of the night. So you don't want that hole to be small. And typically speaking, the cheaper eyepieces tend to have that if they're 6 to 7 millimeters. That's not always the case, but then you pay more for them. 12.5 millimeters is midway flow, and then 25 millimeters is the lower magnification. I always say to people, if you're trying to find an object, go for the lower magnification first to give you the wider field of view that you get with it. Then when you get the object into the center of your field of view, then you can start ramping up the magnification. But note, as you do, the focus is probably going to change. So those are things to consider. And a lot of times now when you buy a telescope to save on price to cost even more, you will get two eyepieces instead of the one, usually the 25 millimeter or the 12.5 millimeter. So that's something else to look out for. What is the Barlow lens? It simply doubles the magnification of the eyepiece. Way more magnification, you're thinking. Not necessarily, because if you can bump up the magnification of something, the contrast is going to drop off and you'll see slightly less detail. So note that while the Barlows are there for you to use, you'll be disappointed if you're expecting real close-up, sharp images. Not going to happen normally, but they put them in because people want them. You're far better getting your brain and eye trained on looking at things that are very small and teasing the best detail out of it. That isn't easy to do. And you won't learn that just by taking pictures. You've got to actually go out there and get and actually visually observe. While I'm here, I'll also say that 2-inch eyepieces are generally the standard issue now, or inch and a half. Inch and a half eyepieces are fine. And if you're going to get one with visual work, you'll get a set of Plusles probably. But if I were you, if you're going to go down a visual line, then investing in a decent set of eyepieces, you will not waste your money. If you're in it for life, go and buy a decent set of eyepieces. The ones you get with it will be okay, but yeah, if you get a decent pair of eyepieces, you'll certainly see the difference. And I went and I think spent about £100 plus on different eyepieces. I didn't buy them all in one go. I bought them over a period of months when my budget allowed. And now I've got them in a case and I can bring these out don't get used very often because the certainly isn't pulled out often, which is unfortunate. They love the eyepieces. But anyway, that's that. Also, one more final thing I wanted to give you is aligning a finder. So how do we do that? Well, you've got your very crude telescope down there, but you can see it's a telescope, albeit on the binary instead of a tripod. Okay, and you've got your finder. So what you're looking to do is get the aerial there, which is on a house, and I tend to take the end part there and get that into central field of view. I've actually got my main aerial out there that's on someone's house, and there's no windows there, so that's the only real problem. If you're trying to align against an aerial and there happens to be a bedroom window as there, you try explaining to the neighbours that you're not a peeping Tom. I have met it, yeah. Anyway, so you get that centralized, and then you come down to your finder and you adjust the bolts until that is on the crosshairs as well. So in theory, once you have that aligned, anything you point the finder at should be in your main telescope. In reality, it doesn't often work out that way for some reason. So I always say to people that when you finally do manage to get a planet or star in view, get it centered, and then see where it is in your finder view. You may then have to adjust it. But once you've adjusted it there, it's usually quite spot on. So, yeah, and I've said there, use the lower the lower power eyepiece, so the 25 millimeter, in other words, that we saw earlier for this, and that won't be easy for you to do. Then when you get it centered there, then put in your highest, your higher eyepiece. That allows you to more finely adjust it, and then that's what you got your crosshairs for there in the finder. Now that may be a bit out of date because we use red spot finders these days. So essentially, then what you do is you may have to adjust the red spot finder so the red spot instead touches on the end of the aerial. And in many ways, that's more accurate, to be fair. And the problem with using a finder with crosshairs in, you try spotting or seeing those crosshairs on a moonless night with a pitch black background. It isn't easy. So that's why the red spot does come in handy. And these days, the red spot finders come as standard with many telescopes. So it's far easier. The only thing to understand is they run on on the watch battery. And so, if that seems to be fading away, no matter how you twiddle it, you may need to change the battery. But that, I think, is pretty much what I wanted to give you. Once again, I'm sorry for this being on the Space Cadets format, but that's the format I did the original presentation in. But this should help you with your observations. If you're going to get a telescope, I hope I've given you the information you need to go and buy one. You shouldn't really need a telescope with your observations. We always say you can use the Liverpool robotic telescope and ask them to take the observations for you, or a pair of binoculars. But for those of you who want to get a telescope, I hope this information is informative for you, and I thank you for watching. And clear skies.